This is OwlUp, where learning happens in minutes, not hours. For a deeper journey, explore all our courses at owlup.co. Now, let's dive in. Welcome back to Chapter 4 of From Pixels to Predictions. Today's episode, titled Training Your First Image Classifier, is all about breaking down the essential components of an image classification model. Whether you're a beginner or just looking to sharpen your skills, this episode will guide you through the fundamentals you need to get started. Let's dive in. Right now, someone is training an image classifier on a dusty old laptop and beating models that once needed a supercomputer. You scroll past a photo, your phone instantly tags dog, beach, sunset. How does a model learn that trick from a pile of raw pixels and a few labels? A decade ago, training a serious vision system meant massive datasets, research labs, and serious hardware. Today, a weekend project on your personal laptop can sort plant diseases, recognize handwritten math, or flag defects on a 3D printed part with accuracy that would have turned heads in 2012. The twist? You don't start from scratch. You stand on the shoulders of giants, massive public datasets and pre-trained networks that already know a lot about the visual world. Your job is more like a careful editor than an author. Pick a focused problem, curate a small but honest dataset, and nudge a powerful model until it speaks your project's language. In this episode, we'll turn that abstract promise into a concrete, end-to-end pipeline you can actually run, debug, and trust. Image models don't start by caring about cats or cracks in metal any more than a spreadsheet cares about revenue. They only see structured numbers. Your job is to turn messy reality into numbers the model can reliably chew on, consistent image sizes, sensible color ranges, and labels that actually match what's in the frame. That usually means throwing away some data, fixing oddities, and resisting the urge to keep every weird corner case on the first pass. In this episode, we'll zoom in on that translation step, how you clean, slice, and stress test your data before the first epoch even runs. Nielsen's old rule of thumb says you need 5 users to uncover most usability issues. In practice, you'll often learn more from 500 carefully chosen images than from 50,000 sloppy ones. The real leverage in your first classifier isn't exotic architectures, it's the quiet, slightly tedious choices about which pictures you keep, how you label them, and what you let the model see during training. Start with scope. A common beginner trap is classify everything, every breed of dog, every kind of fruit, every weather condition. Instead, carve out a tight, boringly specific goal. 3 types of leaf disease, in daylight, from above. Every constraint you add makes your job easier and your results more meaningful. Later, you can deliberately widen that scope and see where the model breaks. Then, get painfully concrete about labeling rules. Decide up front what counts as each class and write it down. If 2 people label the same batch and frequently disagree, your model will be learning that confusion. Simple tricks help. Shuffle images so near duplicates don't appear back to back, relabel anything that makes you hesitate, and introduce a junk uncertain class instead of forcing bad labels. Next, confront imbalance. Real datasets are lopsided, more normal photos than rare failures, more common objects than edge cases. That skew can make a glamorous accuracy number meaningless. Before training, just count images per class. For thin classes, you can oversample, gather a few more examples, or use targeted augmentation, creating plausible variations by flipping, cropping, or slightly altering colors. This is where that single analogy helps. You're not decorating a cake, you're planning the recipe. The same ingredients, measured differently, give wildly different results. Thoughtful pre-processing, resizing, normalization, consistent formats is you deciding how much flour, how much sugar, before anything goes in the oven. Finally, create 3 clearly separated worlds, one for learning, one for tuning, one for judgment. Keep your final test set boringly untouched. When you're tempted to peek at those scores just to check, resist. That self-control is what keeps your eventual results honest. Your challenge this week: Pick a tiny, real problem, even 2 classes, 200 photos each, and do only the data work. Clear scope, explicit label rules, class counts, and a clean train, fasciolated test split. Without training a single model yet, and getting click your data questions. So now, this is Senkel. Think about how real teams do this. A plant disease startup might shoot every leaf on the farm, then discover half the photos are blurry, backlit, or show multiple plants. Their first win isn't a fancy network, it's a simple rule. One healthy or one diseased leaf, centered, in focus. Overnight, their noisy folder turns into something a model can actually learn from. Or consider a side project, screening 3D printed parts for surface defects. At first, every odd shadow gets labeled as a crack. After a week of review, you separate real crack, scratch, and lighting artifact. Confusion drops, and so does the model's future error. The same pattern shows up in medical imaging teams, wildlife camera enthusiasts, even people sorting receipts. They keep refining. Clearer class boundaries, consistent viewpoints, enough examples of the weird cases to matter. Your quiet dataset policies become an invisible contract. Any future image that follows these rules should be treated like this. That contract is what you're really training. Those humble splits and labeling rules won't stay on your laptop. The same habits scale into products that decide which factory parts to discard, which crops to water, which parcels to flag for damage. As tiny models slip into doorbells and thermostats, your early discipline becomes a kind of quiet governance. Each choice about include, exclude, or mark as weird is like drafting zoning laws for a growing city. Invisible when things work, painfully visible when they don't. As you train your first classifier, notice how it subtly reshapes how you look at the world. Suddenly, just a photo turns into questions about lighting, angle, and edge cases, like a chef who can't taste soup without dissecting the seasoning. Follow that curiosity outward. Which everyday decisions around you could quietly benefit from the same kind of careful seeing? Here's your challenge this week. Pick a tiny, real problem in your life. For example, messy versus clean desk, coffee versus tea mugs, or my dog versus other dogs, and collect at least 50 images per class using your phone. Split them into train and valid folders, then use a simple image classification notebook or tool, like FastAI or Teachable Machine, to train your first model. Once it's trained, run at least 20 brand new photos through it and write down the accuracy it got on your mini test set. Finally, tweak one variable, like learning rate, number of epochs, or image size, retrain, and compare whether your accuracy went up or down. This was OwlUp, your daily step forward. To keep learning with structured courses and more insights, go to owlup.co. Until tomorrow!